All right, so today we're talking about acceleration. So first of all, what exactly is acceleration? Acceleration is the rate of change of velocity. In other words, how much time it takes for velocity to change. Remember, velocity is the speed and direction of an object. So when we take a look at acceleration, a lot of times we think of hitting the gas on a car and taking off. Well, acceleration, positive acceleration, is when you have velocity and the acceleration going in the same direction. Okay? So when this happens, the object, in this case the car, will be speeding up. Well, if we take a look at a drag race, all right, and they hit the gas and they get cruising down, at the end of that, what happens? How do they come to a stop? They pop the parachute, and this is what's taking place. Something called negative acceleration. Now, negative acceleration is when you have velocity is going forward in this case, but the change in velocity, all right, in this case, is going the opposite direction. When this happens, negative acceleration takes place, or the vehicle starts to slow down. All right, so here we have a picture. You have these cars are all traveling at 55 miles an hour. All right? They'll have their cruise on. Now the question is, are they accelerating? Hit pause, answer the question, and then once you've answered it, hit play again. Well, in this case, it's not work. Oh, it's unavailable. All right, try this again. So if we look at this, all these cars, they are accelerating. Because remember, acceleration is the change of velocity over time. So if we look at these vehicles, they all have a constant speed, but they're going around a curve, so therefore they're changing direction. Remember, velocity is speed and direction. So all these cars are accelerating. So here we have, if we were going to graph acceleration, here we have a graph where you've got speed is our dependent variable, time is our independent variable, and in a graph that looks like this, at a constant increase, we have a object that is speeding up. Another graph here shows a negative slope, and with this negative slope, the line going downwards, this shows a object slowing down. This would, of course, be negative acceleration. One more here. And so here we have time, then we have speed as the independent or the dependent variable. Now here you have just a straight line. Well, what's going on? Does the speed change? No. So there's no change in speed whatsoever. So this would represent a constant speed. Now, if we're going to calculate acceleration, acceleration can be calculated through taking the final velocity, subtracting the initial velocity, and dividing all that by the total time. We look at the unit label for acceleration. It's going to be some sort of distance over time squared. Okay? When putting these problems in, when you're plugging the numbers, it's really important to make sure that you have the numbers for the final velocity going first and the initial velocity second, because if you switch them around, you're going to get a different slope. And remember, having a positive slope and a negative slope makes a big difference as to whether or not it's a positive or negative acceleration. Then we have something called centripetal acceleration. And by definition, it's acceleration toward the center of a curved or circular path. We're going to talk more about this in a future unit.